In this lesson, we want to talk about solving linear systems using inverse matrices. All right, in the last lesson, we talked about how to find the inverse of a matrix. We found that only square matrices had an inverse and not all of them would have an inverse, right? So when a square matrix has an inverse, it's called non-singular or invertible. If it doesn't have a matrix, it's called a singular matrix. Now, we know that for a 2 by 2 matrix, there's a very good shortcut that we can use to find the inverse. When you get into a 3 by 3 or higher, there are some different options you can kind of employ, but all of them are tedious. They all involve a good amount of work. Okay, so what we want to do here is we want to take the next step and we want to show how we can solve a linear system using an inverse matrix, but it's not necessarily going to be a good method to use. Okay, in a lot of cases, this is going to be way more work. Okay, but it's something that you do need to learn because it's taught in every textbook and you're probably going to get tested on it. Now, let's go ahead and start out with this kind of easy system to get started. We have 8x minus 7y equals negative 17, and we have negative 6x minus 8y equals 26. So the very first thing you want to do is make sure that your equations in your system are in standard form. Okay, just like when we try to set up an augmented matrix, you want the ax plus by equals c. So everything has to line up, your x's, your y's, your constants, make sure all that lines up. Now, the next thing you want to do in this particular case, you don't have to do this. This is just something that I like to do to make things simpler. Notice how everything there is divisible by 2. So I can really rewrite this and say this is negative 3x and then minus 4y, and this is equal to 13. So I'm just going to rewrite my system real quick and say that it's 8x minus 7y is equal to negative 17, and negative 3x minus 4y is equal to 13. Okay, so let's copy this real quick. I'm just going to go to a fresh sheet because things are going to get busy very quickly here. And let me just paste that in. So now what I'm going to do is going to seem a bit strange at first, but I'm going to set up 3 different matrices. Okay, so one's going to be for the coefficients, one's going to be for the variables, and one's going to be for the constants. So the way your book is going to do this, they're going to say that A is going to be the matrix for the coefficients. So if I just grab them in order, I have 8 and negative 7, and then I have negative 3, and I have negative 4. Okay, so that's going to be my first matrix of this kind of equation I'm going to be setting up, which we'll get to in a minute. Then the second matrix is going to be a column vector. So a matrix with one single column. It's just going to have the 2 variables of the system. So I have x and I have y. So I'm going to put x and y. Okay, so this is for the variables of the system. And then I'm going to have a matrix B, which is going to contain these constants. Okay, so let me write that. It's going to be another column vector. So I'm going to say we have negative 17, and then we have 13. Okay, so the way we're going to set this up is we're going to say that A, this matrix here, multiplied by X, this matrix here, should be equal to B, this matrix here. So you might be saying, why does that work out? Well, what happens is if I go through the process of multiplying this matrix by this matrix, I'm going to get entries that exactly match this kind of left side, okay? And it's going to be set equal to this right side here. Now, let me show you that real quick. Let me just kind of scooch this out of the way so we have a little bit of room, and I'll just move this up. It's going to be very tight to do this. But first and foremost, can we multiply A times X? We know A is a 2 by 2, and we know that X is what? It's a 2 by 1. So the columns from A match the rows from X, so we know we're good to go there. And we know the output of this is going to be a 2 by 1, right? The outer dimension, so 2 by 1. So if I do AX, I would get a 2 row, okay, by 1 column matrix. So I would take this row times this column, 8 times X is 8X, and then negative 7 times Y would be minus 7Y. And then for this one right here, I'd take this row times this column, negative 3 times X is negative 3X, and then negative 4 times Y is minus 4Y. Now, again, this exactly matches what we have on the left side here. So let me kind of slide this down now. And let me put some brackets around this. And if we say this is equal to B, B is down here. This is negative 17 and this is 13. This is exactly what we see with our system. Remember, 2 matrices can only be equal if they're the same size. In each case, it's a 2 by 1. Okay, and they have exactly the same elements. Okay, so we're saying that this is going to be equal to this. This is equal to this. Okay, we're saying this is equal to this. this is equal to this. So that's where this equation comes from. I just wanted to show you that so that you're not confused about why this is mathematically legal. Okay, so now let's talk a little bit about how we could solve this equation. Right now, we know what the kind of entries are for A and the entries are for B, but we don't know the entries for X. That's what we'd like to find so we can figure out what X and Y are. So with normal equations, right, linear equations in one variable, it's very easy. We divide both sides, okay, by A, and we can get our solution, right? We would say X is equal to B over A. Well, it's not going to work out that way for us because we can't divide a matrix by another matrix. When we work with kind of matrices, that operation is undefined. So we have to have a different way. And what we're going to do is use some of the knowledge from the kind of previous lessons. And we're going to say that we know if we take A inverse and we multiply it by A, I'm going to get an identity matrix of the same order. Okay, so if I took A inverse, multiplied it by A, I would get I sub 2, right? A 2 by 2 identity matrix. So let's just go ahead and do that real quick. I'm going to slide this down here. I'm going to say I have A inverse times this on this side, and I've got to make sure of the order because it's going to be very important to make sure the order is correct. So I'm going to slide this in on the left. And what happens is on this guy, A inverse times A gives me an I sub 2, and this is times X, and this equals A inverse times B. Now, stay with me for a second. We have X, which is 2 rows by 1 column, and we have I sub 2, which would look like this, right? It would be a 1's going down the diagonal, 0's above and below. So this is my I sub 2. Now, if I multiply I sub 2 by X, first off, is that legal? This is a 2 by 2. This is a 2 by 1. So yes, it is. And I would get X back. Okay, and you can pause the video and do that real quick. You can multiply this by this. You will get X back. So really what I can do at this point is I can just erase this because it doesn't really do anything. It's just like if I had 1 times 5 and I said, okay, well, this is just equal to 5. That's all I'm doing there. So at this point, I can say that X, this unknown right here, is going to be equal to A inverse times B. Okay, so that's where we're kind of going with this. And really quickly, we know that we can do the operation this way because A inverse is going to be a 2 by 2, and B is going to be, or is, I would say, a 2 by 1. So mathematically, we can multiply these together. If you flip the order, though, okay, if I did it like this, if I said I had B times A inverse, you're going to run into a problem, right? Because this is a 2 by 1 and this is a 2 by 2. You cannot do that operation. Okay, so you got to make sure that when you're setting these equations up, you pay attention to kind of which order you're multiplying everything in. All right, so what I'm going to do now is just kind of copy these. We're going to go to a fresh sheet because we're going to run out of room. We'll paste this in here. And I'm going to get rid of this for a second. What I need to find right now, I'm just going to get rid of this too. I need to find A inverse to start this off. So I need to find A inverse, and then I'll multiply it by B, and I'll know what X is. So how do I find A inverse? Again, if you didn't watch the last lesson, let me give you the shortcut real quick. So if we have A, and let's define the entries to be lowercase a, lowercase b, lowercase c, and lowercase d. What happens is if I want A inverse, all I need to do is put 1 over the determinant of A. And we haven't talked about this yet, but it's very easy to find this. It's basically just A times D. So these two multiplied together. So A times D minus these two multiplied together, B times C. Okay, that's very easy. Then multiplied by, what I'm going to do here might not make a whole lot of sense, but we'll kind of get to this later on. So A and D would swap. So D and A, notice how those positions swap. And then B and C, these guys are going to become their opposites. So negative B and negative C. Okay, so this is something you probably want to write down for your notes because we're going to use it a few times today. And the main thing here is that don't be frustrated if you can't memorize this with kind of one go. I've been using this forever, so I already know it. But it's one of those things that after you practice enough times, it just gets committed to memory. So write it down, use it when you're solving your problems, and you'll memorize it very quickly. All right, so let me just erase this. I can do this from memory. And so I'll say A inverse is equal to, it's going to be 1 over the determinant. So this guy times this guy, 8 times negative 4 is going to be negative 32. And then minus negative 7 times negative 3 is going to be positive 21. If I did negative 32 minus 21, that's going to give me negative 53. Okay, so that's the first part of the formula. Then we have to multiply it by, remember we have all this stuff that goes on. So these two switch. So the position of this one and this one, so this becomes up here and this one becomes down here. And then these guys get changed into their opposite. So instead of a -7, I get a 7. Instead of a -3, I get a 3. So from this point, I'm just multiplying a scalar by a matrix. So very, very simple. Let's just do this down here real quick and then we'll replace everything. So -1/53 times -4 would just be 4/53. Okay, so that's going to be your first entry. So it's going to be 4/53. So let me erase this and I'll put this over here. So 4/53. We kind of slide that down because we're going to need some room. So A inverse is going to be equal to this. Then the next one is -1/53 times 3. This is just going to be -3/53. And then the next one is going to be times 7. So obviously that's just going to be -7/53. And then the last one is going to be times 8. So that's just going to be -8/53. Okay. So let me erase this from here and let me try to make this a little bit more compact because we're going to run out of room. So we're going to have 4/53. We're going to have -3/53. We're going to have -7/53. And we're going to have -8/53. All right. So that's about as good as I can do. Now, what we said, and I have to go to kind of the next one. I can erase A. I don't even need it. So what we need to do, let's go back up. We know from this equation, and I can just erase all this, we don't even need this anymore, that x is equal to A inverse times B. Here's B. Let me grab this real quick. And again, you got to do this in the right order. So A inverse is first, B is second. So let me put this in here. Okay, so we're going to say that we have A inverse times B. Again, this is a 2 by 2, and this is a 2 by 1. So we can do this. These numbers match, and it's going to be a 2 by 1. So a 2 by 1. So you're going to have one there and one there. So let's go ahead and crank this out real quick. We want to start out with this kind of entry here, and that's going to come from this row times this column. So you're going to have 4/53 times -17. That would be -68/53. So -68/53. And then you'd have plus, you have this guy times this guy. So -7/53 times 13. So that's going to give me -91. Okay, -91/53. So if I add -68 and -91, I get -159. So this would be -159/53. And if I do that kind of calculation, I'm going to get -3. Okay, so this first entry here is going to be -3. All right. So now I just need this entry down here, and all I'm going to do is get kind of this row times this column. Okay, so -3/53 times -17. We know -3 times -17 would be +51. So this is +51/53. And then you're going to do this guy, which is -8/53. Okay, times this guy, which is 13. So that's going to give me -104. Okay, so -104/53. You can add these two together. So you're basically doing -104 plus 51, which gives me -53. So you know what this is going to be. It's -53/53, which is -1. Okay, so at this point, we've found our answer. A inverse times B is x. So let me just copy this real quick, or I can copy the whole thing. Okay, so let me paste this in here real quick. And we know that A inverse times B is x. So let me just kind of replace this, and I can replace this, and I'll just drag this up here. So we have our solution, right? This guy represented x, this guy represented y. So we can say that x is -3 and y is -1, okay? So let me erase all of this, and we can just check this real fast. I know this process is very tedious, and again, it's not a recommended method. If you used any other method, you'd be done a long time ago, right? But it's just something they teach, so we do want to cover it. All right, let's check this real quick. If I plug in a -3 for x, I get 8 times -3, which is -24. And then -7 times -1 would be +7. Does this equal -17? Yes, it does. And then for this one, you get -3 times -3, which is 9. -4 times -1 would be 4. So +4 equals 13. That works as well. All right, let's take a look at another example. So we have 3x minus 9 equals 3y. We have -8y equals 48 plus 16x. So in this case, we have to do some cleaning up, right? We can't just start because everything would get messed up. You want every equation in ax plus by equals c. And here you have some opportunities to kind of work with smaller numbers, so you want to take advantage of that. I'm going to, for the first equation, I'm going to subtract 3y away from each side, and I'm going to add 9 to both sides. And then I'm going to divide everything by 3. So this is going to give me x minus y equals 3. So this is going to be my first equation. Let me just kind of drag this up here. And we're going to bring this to another sheet, so don't even worry about this right now. So I'm going to subtract 16x away from each side here, so minus 8y, and this equals 48. For this one, everything is divisible by 8, right? Because you divide this by 8, you get negative 2, then times x. You divide this by 8, you get negative y, and this equals, you divide this by 8, and you get 6. So you can say this is negative 2x minus y is equal to 6, okay? So you can look at that and say that, hey, I could solve that with substitution in probably like less than a minute, but we're going to do this using the kind of inverse of a matrix method, which will probably take us about 10 minutes. All right, let's go ahead and paste this in, and let's set everything up. So the first thing I want is matrix A, which is going to be the coefficients. So you have a 1 and a negative 1. You have a negative 2, and you have a negative 1, okay? Then I want my matrix X, which is going to be, again, a column vector with X and Y. Then I want my matrix B, okay? Let me write that here. B is going to contain a 3 and a 6, okay? Again, another column vector. So we already know that this sets up to be A times X is equal to B. We've already shown that that's legal. And then we also know that if I multiply this side over here by A inverse, and again, slide this down, as long as I do it on the left side, I am good to go, right? A inverse times B. Because again, this is a 2 by 2, this is a 2 by 1. So this way is legal. If I flip it around, it's going to be illegal. Okay, it's not going to be defined. So A inverse times A is the identity matrix. And again, it would be a 2 by 2. And this is a 2 by 1. So that's legal. So I would get X back. So X would be equal to this. So I need to find the inverse of A multiplied by B. And again, I'll have my solution for X. So let's copy A real quick and go to the next sheet. And we're going to quickly find the inverse now that we know the method. So again, it's 1 over the determinant. Multiply this by this. 1 times negative 1 is negative 1. Then minus this times this. Negative 1 times negative 2 is positive 2. If I have negative 1 minus 2, that's going to be negative 3. So this is negative 1/3 times, interchange these two. So what I want to do, again, this one and this one, they change positions. So this becomes negative 1 and this becomes positive 1. And then what I'm going to do for these, for this one and this one, I change the signs. So this one becomes positive 1 and this one becomes positive 2, okay? So again, when you see that, it might not make sense the first few times, but then after you practice, you're going to very quickly memorize this kind of formula. It's a very good shortcut. All right, so if I multiply everything by negative 1/3, I'm going to get basically positive 1/3 here. I'm going to get negative 1/3 here. I'm going to get negative 2/3 here, and I'm going to get negative 1/3 here. So this is the inverse of A. So this is A inverse. And let's just move this over here. And I'm going to erase A at this point. I don't need it anymore. It serves me no purpose. I need to go back up and get B. So let's copy this and let's go back down and paste this in. And so now I want A inverse times B again in that order because it's only defined in that order. So A inverse times B, again, this is a 2 by 2 and this is a 2 by 1. So the dimensions will be 2 by 1. Okay, so let's go ahead and set this up. We do this row times this column. So you have 1/3 times 3, and then plus you're going to have negative 1/3 times 6. So what's that going to give me? 1/3 times 3 is 1. And then you have negative 1/3 times 6. This cancels with this and gives me 2. Negative 1 times 2 will be negative 2. So this is negative 2. So what's 1 plus negative 2? That's negative 1. So this is negative 1. And then for this one, and I shouldn't put that bracket in there. For this one, I'm going to go this row times this column. So negative 2/3 times 3 plus negative 1/3 times 6. And of course, this is going to cancel. You'll have negative 2. And this cancels with this and gives you 2. Negative 1 times 2 is negative 2. And so this is going to give me negative 4, right? Negative 2 plus negative 2 is negative 4. So we found our solution. We know x is -1 and y is -4. So let's go ahead and copy this real quick. Just go back up and prove that to you real fast. So let me just paste this in here real quick. So we know that A inverse times B is x. So let me erase this and I'll just slide this down. Okay, so we can record our solution. We know this one is x, so x is -1. We know this one is y is -4. I'm just going to erase everything at this point. We don't need it anymore. Just going to list our solution and be done. So we'll say that this is -1, -4 as an ordered pair. Again, if you want to check, I highly recommend it when you start. -1 minus a -4, so +4 equals 3. Yeah, that works out. And then this one is -2 times -1, which is 2. And then minus a -4 is +4. Does that equal 6? Yes, it does. So that's the correct solution. All right, so let's wrap up our lesson and look at a more challenging problem, or you could say a more tedious problem. We're going to look at a linear system with 3 variables. And again, we're going to solve it by kind of finding the inverse of one of the matrices that we set up. Now, again, I just want to emphasize this. This is definitely not the best method to do it. It's just something we're showing you because you will probably be tested on it. All right, so the first thing you want to do if you get a 3 variable system, again, you've got to make sure these equations are set up correctly first. If you don't, it's going to give you the wrong answer, right? So you got to make sure that the x's are lined up, the y's are lined up, the z's are lined up, the constants are lined up, so that when you load the information into your kind of matrices that you're setting up, everything corresponds correctly, okay? So you're going to have a column with the coefficients for x's, then a column with the coefficients for y's, so on and so forth. So in this format, we have everything as ax plus by plus cz equals d. So we're good to go. But again, if it wasn't like that, you'd have to set it up correctly. Now, what I'm going to do is I'm going to make a coefficient matrix just as I always have. I'm going to call it A. And so I'm grabbing all the coefficients. So this has an implied coefficient of 1. This is going to be -3. This is going to be +2. So that's from the first equation. That's this one, and that's this one. Okay. From the second equation, I would have a2, I would have a -5, and I would have a +3. Okay, so again, just to highlight, that's from here, here, and here. Okay, and then from the last one, I've got a 3, a -6, and a 4. And again, that's from this one, and this one. Okay, so all I did was I set up a coefficient matrix, and I'm just calling that matrix A. Now next, I'm going to set up a matrix that's going to represent the variables of the system. We're going to call that capital letter X. And so that's going to have 3 variables, X, Y, and Z. So X, Y, and Z. So this is just a column vector. And then lastly, I'm going to have my matrix B. Okay, so I'm going to write that up here. So B is going to be a column vector with my constants. So again, it's going to be -24. It's going to be -39. And it's going to be -49. Okay, so we know from the previous 2 examples that if I do A, the coefficient matrix, times X, the variable matrix, I can set this equal to B, right? This kind of matrix with my constants in it, and that would represent kind of our system, right? So you can prove that to yourself. You can stop the video and you can multiply A times X and set this equal to B, and you'll see that you get the same thing. All right, so what we want to do now is kind of set up the solution for this, and we already know how to do it. So let me kind of slide this down just a little bit so we have a little room to work. It's going to be pretty tight. So we already know this is going to set up as A inverse times A times X, and you don't need those dots there, but I'm just putting them there for emphasis, is equal to A inverse times B, okay? Now, we know that A inverse times A is going to give me an identity matrix, and in this case, it's going to be a 3 by 3. So this would be an I sub 3 times X is equal to A inverse times B. Now, we already know that if I multiply a 3 by 3 identity matrix by a 3 by 1 matrix X, I'm just going to get X back, okay? So I can really erase this. I don't need it anymore, and I can just declare that X is equal to A inverse times B. Of course, we already knew this from kind of previous examples, but again, it's just good to go over it again. So really all I need to do here is find A inverse, multiply it by B, and then I'll have my values for X, Y, and Z, okay? So let's copy A, and let's find the inverse first. That's going to be the hardest part. All right, so what we want to do right now is find the inverse of A. Again, we talked about this in the last lesson. For a 2 by 2 matrix, if it's got an inverse, it's very easy to find. There's a shortcut. For a 3 by 3, there's a variety of methods that you can use. And we'll talk about another method kind of later on after we talk about determinants. For now, it's a little bit beyond us. But the method that we know, the method that we learned in the last kind of lesson that works for any kind of invertible square matrix, what we do is we set up an augmented matrix, and it's going to look something like this, okay? So let's say A is an n by n matrix. In this case, it's a 3 by 3. And then you have I, which is the identity matrix. In this case, it would be a 3 by 3. So you're setting up an augmented matrix where A is on the left, the identity matrix is on the right. You're going to use row operations to put it in this form. So you want the identity matrix on the left, and your A inverse is going to be on the right. And again, we talked about why this works in the last lesson. So let's go ahead and set this up real quick, and we'll get our solution. So I'm going to start with just this guy right here. I'm just going to erase the A equals. I'm going to put a vertical bar here, and I'm going to put a 1, 0, 0, a 0, 1, 0, and a 0, 0, 1. Okay, so this is just the identity matrix on the right, and this guy on the left is our A, the matrix we're trying to find the inverse of. So we're going to use our row operations to put this side, you could say in reduced row echelon form, or we could say it's going to become an identity matrix. It's just going to match this over here. So the very first thing we want to do, if we follow the method that's given in every textbook, is we want to get a 1 there. And we already have that, so we don't really have to do that. And then based on that 1, we're going to get our zeros. So we want a 0 here, and we want a 0 here, okay? So what I'm going to do is I'm going to multiply this top row here by -2, and I'm going to add the result to row 2. So I'm going to notate that by saying I have -2 times row 1, and I'm going to add the result to row 2. That's what I'm going to replace row 2 with. So let me just go through and multiply -2 by everything in row 1. So -2 times 1 is -2. -2 times -3 is +6. -2 times 2 is -4. -2 times 1 is -2. And then -2 times 0 is going to be 0 in each case. So for both of those, okay? Now, what I'd want to do is add each of these to the kind of entries in row 2. That's what I'm going to replace row 2 with. So -2 plus 2 is 0. Then 6 plus -5 is 1. Then -4 plus 3 is -1. Then -2 plus 0 is obviously -2. And then in each case, I'm adding 0 to something, so it's not going to change. So that part's done. So now I move to this row right here, and I want this to be a 0. So what I do is I multiply row 1, okay, row 1 by -3, okay, and then I add the result to row 3. That's what I'm going to change row 3 with. Okay, so let me just multiply everything by -3 first, get that out of the way. -3 times 1 is -3. -3 times -3 is +9. -3 times 2 is -6. -3 times 1 is -3. And of course, -3 times 0 in each case is 0. Okay, so now we're going to add each of these to the entries in row 3. So this is going to be a 0. 9 plus -6 would be 3. This is going to be a -2, right? 4 plus -6 would be -2. And then in each case, here and here, I'm adding to 0. So it's just going to be -3 and 0. And then here, 0 plus 1 is just going to be 1, right? So this is going to be my row 3. So now we're going to move to this column here. And conveniently, we already have a 1 again, so we don't have to do anything there. We just need to use that 1 to get our 0 here and our 0 here, okay? So I'm going to multiply row 2 by, I'm going to get rid of this one first. I'm going to make this a 0. So I'm going to multiply row 2 by +3, and I'm going to add the result to row 1. That's what I'm going to replace row 1 with, okay? All right, so let me multiply everything by 3. So I'm going to go ahead and say 0 times 3 is 0, and then 1 times 3 is 3, and then 3 times -1 is -3. 3 times -2 is -6. 3 times 1 is 3. And then 3 times 0 is 0. So let's add everything. So 0 plus 1 is still 1. 3 plus -3 is 0. -3 plus 2 is -1. -6 plus 1 is -5. And then we have 3 plus 0, which is 3. And then obviously 0 plus 0 is 0. So that takes care of that. Now we move into kind of making this into a 0. So multiply row 2 by -3. Add the result to row 3. That's what I'm going to change row 3 with. So -3 times 0 is 0. -3 times 1 is -3. -3 times -1 is 3. -3 times -2 is 6. -3 times 1 is -3. And -3 times 0 is 0. So let's add now. 0 plus 0 is 0, so I don't have to do anything there. Negative 3 plus 3 is 0. We have 3 plus negative 2, which is positive 1. Now we just have 6 plus negative 3, which is positive 3. We have negative 3 plus 0, which is negative 3. And of course, 0 plus 1 is 1. All right, so looking pretty good so far. As we move to the next column, again, conveniently, we already have a 1. So we just need to get a 0 here and here. Now, we have the same number in each case. We have a negative 1 and a negative 1. So whatever I do to make this into a 0 will also make this into a 0. So we can kind of do this as one step. I'm going to break it up into 2 just so you don't get lost, but you could do it as one step. So really what I need to do is just multiply row 3 by 1, okay? Or you could just say you have row 3, and add the result to row 2. That's what I'm going to replace row 2 with. And again, it's going to be the same thing. I'm going to multiply row 3 by 1 and add the result to row 1. That's what I'm going to change row 1 with. Again, because in each case, 1 plus negative 1 would give me 0 there. Now, if you want to write a 1 there just for emphasis, that's fine, but it's the same thing either way. So let's start with kind of this one. I'm just going to add the entries in row 3 to row 2. That's what I'm going to replace row 2 with. So 0 plus 0 is 0, no change there. 0 plus 1 is 1, no change there. 1 plus negative 1 is 0, okay? And then 3 plus negative 2 is going to be 1. Negative 3 plus 1 is going to be negative 2. And then 1 plus 0 is 1. Okay, so that one's done. And then lastly, we're going to have 0 plus 1, which is 1, 0 plus 0, which is 0, 1 plus negative 1, which is 0. And then we have 3 plus negative 5, which is negative 2. We have negative 3 plus 3, which is 0. And we have 1 plus 0, which is 1. Okay, so now we're finished. And essentially, you see that you have the identity matrix. You have an I sub 3 here on the left, and you have your A inverse on the right. Okay, so we can just copy that real quick. A inverse is going to be equal to, you're going to have this negative 2, 0, and 1. Then you're going to have 1, negative 2, and 1. And I didn't make my bracket big enough. And then 3, negative 3, and 1. So let me copy this real quick. And we'll go to a fresh sheet. And let's paste this in here real fast. All right, so let's get rid of all this. Now, we need to, let me kind of go back up. We need to multiply A inverse, which we just found, times B. And that's going to give me X. These 3 entries here that are going to give me the solutions for my system. So let me copy B real quick. And let me paste this in. And remember, we've got to do this in the correct order. If I do A inverse times B, it's defined. If I do B times A inverse, it's not defined. Okay, it's not going to work. So A inverse times B is going to be equal to what? Well, again, I know that this is a 3 by 3 and this is a 3 by 1. So it's going to end up being a 3 by 1. So you can have 1, 2, 3 entries here. Let me make that a little better. So for the first entry, let me kind of slide this up just a little bit. For the first entry, what I'm going to have is this first row times this column. So in each case, let me just kind of set this up so we can blow through this. In each case, when I'm multiplying a row by a column, this isn't going to change. So in other words, I'm going to have negative 24, I'm going to have negative 39, and I'm going to have negative 49. Okay, so let me just kind of wrap these. And I'm going to copy this real quick. And I'm going to paste it twice. Right there. And I'm going to paste that again just to save us a little bit of time. Okay. So what's going to happen is I'm going to multiply again this row by this column. So you'd have negative 2 times negative 24. So let's put negative 2 here. Then plus, you're going to have negative 39 times 0. And then negative 49 is going to be multiplied by 1. Okay. So we can do that real quick. Negative 2 times negative 24 is 48. This is 0. Okay. So you have 48 here. This is going to be negative 49. So this is going to be negative 1. So that is your first entry. So this is negative 1. Then for this one, again, you're doing this row times this column. So 1 times negative 24 is negative 24. Then plus you have negative 2 times negative 39. We know that's positive. And 2 times 39 is 78. So let's just say this is 78. And then you have this 1 times this negative 49. So that's just negative 49. So what does this come out to? If I do negative 24 plus negative 49, I get negative 73. If I add that to 78, I get positive 5. So this will be 5. I can kind of get rid of these bars at this point. I just have this one left. So this row times this column. So you have 3 times negative 24. That's negative 72. Okay, so negative 72. Then plus, you'd have negative 3 times negative 39, which is positive 117. So let's put 117. And then lastly, you'd have 1 times negative 49. So let's put plus negative 49. Okay, so what is negative 72 plus negative 49? That's going to give me negative 121. So I'm going to put plus negative 121. And if I do 117 plus negative 121, I get negative 4. Okay. All right. So again, it takes a lot longer to do it this way. I think it's kind of cool if you do this just a few times just to kind of get the concept down. But then again, it's not an efficient way. If somebody gave you the inverse to start, then maybe it'd be pretty quick to use this because all I'm doing is some very simple matrix multiplication to get my answer. But if you don't have the inverse, if you have to calculate it, even with the shortcut that we're going to learn kind of in a few lessons, it's still going to be a very tedious process, and it's going to be easier to use other methods like Cramer's rule, which we'll be talking about here shortly. All right, so let me kind of copy this, and let's go back up, and I don't know where I'm going to fit this. Let's just kind of paste this in here for a second. And let me just erase some stuff here. We know that x is equal to this. So I'm just going to erase this and just kind of slide this down. We know that this first entry was x, this was y, and this was z. Okay, so x is negative 1, y is 5, and z is negative 4. So let's erase everything now. Don't need anything anymore. We've found our solution. So as an ordered triple, I'm going to say it's negative 1, it's 5, and it's negative 4. Okay, and we can just check this real quick just to make sure we didn't make a mistake. So in this first one, you'd have negative 1. You would have minus 3 times 5, then plus 2 times negative 4 should be equal to negative 24. Well, if I do my multiplication first, this is 15, and this is negative 8. So you can say that you have negative 1 minus 15, which is negative 16, minus 8, which is negative 24. So this one's good. All right, for the next one, we have what? We have 2 times negative 1, which is negative 2, minus you have 5 times 5, which is 25, plus you have 3 times negative 4, which is negative 12. This should equal negative 39. Negative 2 minus 25 is negative 27. And if you add negative 27 and negative 12, you do get negative 39. This one's good to go. So for the last one, you have 3 times negative 1, which is negative 3. And then minus 6 times 5, which is 30. And then plus 4 times negative 4, which is negative 16. This should equal negative 49. And of course it does, right? If you do negative 3 plus negative 30, you get negative 33. And negative 33 plus negative 16 is negative 49. So it works in all of them. Again, not the fastest way to kind of go about this, but it's good to have the concept down. It's good to understand how you can kind of solve something using this method. Again, if somebody gave you an inverse to start, it would be a decent kind of technique to use. But if they didn't give it to you, it would probably be a much slower method to use.